My name is Aki Nishimura. In case anyone is curious, it will be Nishimura Akihiko in Japanese pronunciation, and I'm assistant professor in the department. And when I was undergrad, I went pretty deep in theoretical math, and I continued studying math in graduate school. But during PhD, I started thinking more seriously about what kind of mark I wanted to leave on the society. And then I wasn't so sure if I wanted to continue doing such an abstract research. And that was when I started shifting more toward research inspired by concrete applications. And it took additional several years of search for purpose and wrong turns before I discovered that there's a discrete field called biostatistics where I get to work on challenging mathematical problems, learn interesting science along the way, and make a real world impact. I use my expertise in Bayesian method and computational statistics to address challenges in large-scale analytics of biomedical data, especially those from electronic health records and administrative claims. So I can put my research interest broadly into three categories: health data analytics, Bayesian methods, and computational statistics. And my research on health data analytics is very much driven by the goal of how we can turn observational health data into reliable clinical evidence. I'm always up for important public health problems where I can, involving large complex data sets on which I can unleash my Bayes and computational expertise. So for example, I've been collaborating with my colleague Niranjan Chatterjee on the problem of predicting genetic risks from the people's genetic markers. So through my research, I'd like to help make the clinical decision making more evidence-driven based on hard data. So much of the current clinical practice is based on very limited scientific evidence, some of which are not much better than personal anecdotes. So I've been working with involved in a global effort to build a data science infrastructure to generate scientific evidence from health data. I often think about the more symbolic impact we could have as researchers on the future of our disciplines, because we all follow others' footsteps to some extent. Specifically within the Bayesian computation community, I'm one of the very few who is based in biostatistics and with hands-on knowledge of the domain-specific knowledge and details that makes all the differences in practice. Much of the computational research is too focused on idealized settings and not adequately addressing the practical challenges. And this is unfortunate because computational innovations can really drive our field forward in enhancing our ability to extract insights from large complex data sets. And so I would be delighted if some of the students and junior researchers in my field see my research, find it exciting, and decide to follow the same path, bridging foundational research with hands-on applications. I like our school a lot because people are not only exceptionally talented, but are deeply committed to making real societal impact. And people are very collaborative, and they understand that it takes a teamwork to address societal challenges. So the main course I teach is the third term of our data science sequence. The course is called Statistical Computing, Algorithm, and Software Development. And it covers a broad range of topics and teaches skills I consider essential in analyzing large complex data sets commonly encountered in modern applications. A lot of things I teach in the class skills, foundational skills I use every day in my research, but nobody taught me. So in a sense, it's a class I always wanted to take myself.